Any issues? Anything you want to ask? So from your side, you can do what? You can also, if you have free time, you can also look for some previous year CSIR questions on your own. Okay. And try to complete the questions along with the lecture itself. If you do so, then you will gain a lot of confidence and you will get a lot of satisfaction also that whatever you are studying, you are getting the questions right out of it. Okay? So that's why I'm saying that you should focus on previous year questions a lot. They are the like means they are your savior, I can say. If you for any competitive exam, the previous year questions are the most important thing that you can focus on. Lectures are also important, but what kind of things can be asked? For example, from any slide like this, what kind of things can be asked? What can you can think of? Okay, so that you don't know what type of question can be arise from the content, from the theory that sir taught you, or what we have read from the books. Okay, so go to see previous year CSIR-NET questions, and apart from CSIR-NET, you can also go for some GATE and JAM and other subjects specifically. I'm telling you, and practice a lot of questions. Okay, we also conduct some previous year question solving sessions after completing some syllabus. Okay, so don't worry about it, but you should also do it from your side. Okay, now we should move. This we have completed yesterday, which is the introductory part. You know what is the significance. So questions, few of questions that I have mentioned here. You can go through it. Okay, can anybody can answer these questions? So first question is like the world's ocean covers about how much of the ocean surface. So I can move to this slideshow mode so you can see the questions properly. Can anybody of you answer this question? Very basic fundamental questions from the previous lectures. So the world's ocean covers about how much of the ocean surface? Sorry, I should write it. Total surface. Okay. Not ocean surface, total surface. My mistake from my side. Okay, so it is around 71%. The answer is around 71%, and the rest 29% is the area covered by the land. Very fundamental question. The average depth of the world ocean is closest to. So they are just not asking you the exact value. So they are asking you some approximate value that I have told you that you can remember that if you couldn't be able to remember the exact figure in meters, then you can remember, okay, it is around maybe 3.8 kilometers, something like that. Okay, that we have discussed yesterday. So it is around 3.8 kilometers or 3800 meters, this much depth. So after the oceans, the next biggest reservoir of water on earth is, whether it is ice, the atmosphere, fresh water, rivers, lakes and streams, or groundwater. So we have discussed about there's a storage of water in different reservoirs, like in atmosphere, in soil moisture, as a groundwater, in human beings also, in living beings also, and then in lakes, then in rivers, in polar ice caps. So if you see the graph, if you see that image that I have put, so in that case, after the oceans, the majority of the part of water is stored in the ice caps. Ice caps such as the Antarctica, the Greenland are the ice caps. Understood? Now, 1 fathom. Fathom is a unit that is being used to measure the depth of the oceans. ठीक है ना, is equal to how much feet? Okay. So when we used to measure the depth, we have to report the depth. Okay, how much depth this submarine is. This submarine is going. Okay, moving. So we usually note in fathoms. So it is around 1 fathom is equal to 6 feet. The largest and the deepest of the oceans is the, okay, so you can refer to this slide. All things are mentioned here. Sorry, wait a second. Yes, this one. So you see that the figure is given here, that according to the depth of the oceans, the Pacific, the Atlantic, the Indian, and the Arctic, and also the percentage of area that is being covered by respective oceans. Okay, so these are the 4 major ones, and you see that Pacific covers the most, which is around 50%. Then you have the Atlantic, which is around 26%, Indian 20.5%, and then Arctic. So you just remember some rough values. You can just take a 50, 26, 21, and a 4%. Just remember like that. And if they ask you, just tell me the sequence. Okay, so obviously the Arctic is the less, then you have Indian, then Atlantic, and the maximum is the Pacific. As you see, it is the, in this particular globe, the distribution of the oceans has also been mentioned. The Atlantic Ocean, the Pacific Ocean, the Indian Ocean, and the Arctic Ocean. So Arctic Ocean, you see that it is being there in the northern part, that I've told you, in the northern part especially. The Pacific Ocean, which is the world's deepest ocean. I hope you can able to see this thing. Just wait a second. Okay. So it is the world's deepest and the largest ocean. That is within your this Pacific Griddle of Fire that we should discuss in the upcoming lectures. If you don't know about this, okay, it is a part that is usually covered in physical geology. So this is the Pacific Ocean, and it is being bounded by Americas and the Asia on the right and the left side respectively. Then you have this Atlantic Ocean, which is the second largest ocean, which is between this American continents and Africa and Europe. So this particular, so they are confined. So they, if you see that these, they don't usually have what you say exact boundaries that is separating from. So, but still they have made some approximate boundaries. You see that this strip, this pink color strip, is separating. Okay, this is the Atlantic on this side. Okay, and this is the Pacific on this side. Understood? So as you can see, this strip is going from this southern part of this Africa, which is the Cape Town, and up to this Antarctica. So this particular strip, as you see, this pink color strip is separating this Indian Ocean from this Atlantic Ocean. Okay, and you also see some lines. Okay, I can zoom that. You can zoom that, so you can see them properly. Okay, just see this pink color strips that are surrounding. That is something in the northern part of this Great Britain, connected to this Iceland. This is a small island, Iceland, then to Greenland, then to some this Nova Scotia, and you see in this northern part of this another eastern part of Canada. Okay, then you have this Bering Strait that connects. This is a strait that separates this Russia from the Alaska, USA. Okay, this is a small strait. So this particular belt, if you close them, then this will define your area of the Arctic Ocean, which is the most smallest one and the shallowest one. Okay, so you should remember this thing. And you see that Indian Ocean is also there, obviously. So southern part यहाँ से शुरू होता है आपका, your Arabian Sea or Bay of Bengal, all are the part of this Indian Ocean. Understood? All are the part of this Indian Ocean, and most of this part, you see that this is a 0-degree line. This line, as you can see here, will highlight for you people. This is the 0-degree. So this is the equator, and below this equator, you see that majority of the Indian Ocean is lying. Okay, so northern hemisphere में नहीं है इतना. So this tip of this India, which is the Kanyakumari, it is around 7-degree. Okay, it is around 7-degree. This is the equator. It is around 7-degree latitude difference from here, from the tip of India, southern tip of India, up to this equator. And you see that majority of the part of the ocean is below this. Okay, so this is the boundaries. Understood? This is very important. So, which is the largest and the deepest ocean? Now you know it is the Pacific. Any question? Any doubt? The southern hemisphere has more ocean coverage than the northern hemisphere. Obviously, we know, we have seen this distribution of the land and the ocean in at different latitudes. So we can say yes for it. Okay, so this is a typical NET type question that you can do. So it is mentioned. So there is a survey that is going on where we used to measure the depth of the ocean. So how the depth of the ocean is being measured? It is being measured by the help of some sonar. So we used to send some signals, okay, some echoes. It is similar to that how dolphins or a bat locate itself by echoing. So when that particular sound waves hit any substance, any object, and reverts back to its source. So from that we can able to that animal also, and that creature also, and our instruments also can be able to estimate, okay, in how much time the signal has came back. So according to that, obviously the sound of the sound waves is well known, because our instruments only has sent that sound waves. So the velocity of those sound waves are known, and your what do you call it, your time is noted down, and from the basis of that you are able to measure the distance. Okay, the distance means obviously the depth. Okay, we are talking about the depth. So they know that the sound waves are moving at the velocity of about 1500 meters per second through the water, and the echo sounder sends out a signal whose echo returns 6 seconds later. 6 seconds later. Okay. So your what is known? Your velocity is known, which is this, and your time is known. Sorry. Okay. So we call it velocity is equal to depth in our case upon the time. So now you have to do one thing, that sound signals have gone here and again came back like this. So they have traveled 2 times that same distance. We have to know the half of it. Okay, पहले वो नीचे गया, then again वापस से ऊपर आया. So we have to note the half of it. The half of it, the total distance is something else. ठीक है ना? So you should write this thing. The total distance is equal to, I hope you are getting this, is equal to depth. Okay, it came and hit to the oceanic bottom and again gone back. We are assuming that the reflection is somewhat kind of this. If the reflection is this, then the thing would be something different. and then the solution would be something else. So we have to assume, okay, these are the triangles, and we have to use the Pythagoras theorem and some trigonometry to solve those things. So we are just assuming a simple that okay, a ship is there and it sent signals, and that signals hit back the ocean floor and came to its receiver. So what you do, just multiply it with the 6 seconds because it is meter per second into 6 second. So this will be cut down upon 2. So you can solve it. So it would be 3. So answer would be 4500 meter. I hope you got this thing. So the answer would be 4500, and this is acceptable value. Okay, this is acceptable value. Our ocean can lie somewhere, the depth can lie somewhere 0 meter up to 11 kilometers in the Mariana Trench. So the value is our value, whatever value we have got by solving this question, is somewhere lying in this range. Okay, in this range only. So this is good. Anything you want to ask? Any queries? Hello? No issues? You are able to understand each and everything? Okay. I hope you got the previous lecture. Now we should move to the next lecture, which is the morphologic and tectonic domains of ocean floor, which is the second part. So we have completed with this first part, which is the introduction to oceanography, and the second part we are trying to complete the morphology and morphological and tectonic domains of the ocean floor, as well as structure, composition, and mechanism of the ocean formation of the ocean crust. Okay, so the third part, which is the structure, composition, and mechanism of the formation of ocean crust, we should complete it first, and then we'll move to the second part. Okay. So now we move. Okay. So the important thing is, first we should understand, because we just take it that this is the first lecture. That is not the first lecture, it is the introductory part. Just take it lecture 0. This first lecture we have started right now. So how the ocean crust has been formed, that you have to understand. So it is the aspect that usually covered in this crustal evolution and tectonics. So as you know that the age of our planet is around 4.5 gigaannum. Okay, this is the age of our planet I have mentioned here. Okay. And you know how our planet has been formed with the nebular hypothesis. If you don't know, then you should go through the nebular hypothesis. We are not completing covering that aspect here because it is a part of some other subject. Nebular hypothesis, where this nebula of hot gas and particles coalesce down and accreted down for the formation of planetesimal, and the planetesimal aggregated and the form subsequent planets that we usually see today. So, so these are the main dominant heavy elements that existed in that nebula that we can see in the chemistry of our planet also. So Earth was very hot during the Hadean time. Hadean time is around more than 4.0 G. If you see the geological time scale, I hope you have seen this Hadean geological time scale or international chronostratigraphic chart. So this is the heading. It is time period right away from 4.0 GA up to 4.56 GA since the inception of this planet. Okay, this is the range. 0.56 GA is the range of the Hadean era. So during the cooling, Earth differentiated. So what is happening that, okay, That nebula is there, it is cooled down, and now the things are trying to resettle itself. ठीक है ना, resettle itself, because सब चीजें एक बार में आके कोलेस कर गई थी, जुड़ गई थी एक समय। Now things are trying to resettle itself based upon what is their densities. Okay. So currently you see that Earth is divided. This Earth is divided into 4 components. Okay, which we call it the crust. You can, obviously we know that we can further divide the crust into upper crust, middle crust, and lower crust. But we say for now we can say it's a crust because we are not dealing with that aspects. Okay. Then mantle. Okay, we can define. We can divide mantle into upper mantle, low velocity zone, and your lower mantle. Then we have this outer core and the inner core. So these 4 are the main ones that you should remember. Ultimately, there are different subparts also. Like we have low velocity zone, we have transition zones, we have D dash layer, D double dash layer. Different discontinuities are there that are separating these different layers. Okay, how we got these layers? How we got? If we take this part, the crust, like a pizza slice. Sorry, up to this part, up to the center. I should use some different taking up to this much part. So this upper part is the crust. Then you have mantle, upper mantle, lower mantle, crust, core, inner core, outer core, all these things. What is the basis of the development of these layers? The basis of the development of these layers is the density contrast of the different elements that are present in the solar nebula. And when these different elements, what they happen, they are trying to resettle itself. Means obviously the elements, the periodic table, that different elements are there right away from the hydrogen up to the uranium, which is the most heaviest one. So I would say hydrogen is 1, and you have uranium, which is 92. Okay, this is the range. Other there are some elements that have atomic number and atomic mass more than that of uranium, but uranium is the heaviest natural occurring element. All those elements that are they are present there over uranium are formed artificially by some uranium fusion of fission reactions. So this is the range. So you see that hydrogen is the most lightest one because the atomic number something corresponds to this atomic mass, and ultimately atomic mass also defines what is the density as well as how much heavy the element is. Hydrogen is the lightest one, while the other metals that we used to see in the periodic table, like particularly in the D block elements, we call it, are heavier ones. So what they are trying to do, they are trying to settle down. Where they have settled down, obviously they will settle down in the bottom part. Okay, na? In the bottom part. In the bottom part of the because everything is molten during that time. Everything is molten, so things can go down. It is not fully crystallized. Till date is not fully crystallized. Okay, a lot of convections and other phenomena that usually happens in fluids happens in the this inner part of the earth. So things are trying to settle down based on their density. So the heaviest elements that have the highest densities are settled down in the in the inner core, that are particularly iron and nickel. Okay, so inner core comprises of iron and nickel and some proportions of the sulfur and your platinum group of elements. Okay, so platinum group of elements, if you talk about in periodic table, which is the most densest element set of elements that are present in the periodic table, those are the platinum group of elements like the iridium, platinum, and palladium, your osmium, rhenium. These are the set of elements at the higher density, that is the highest density. Like the density can reach up to like 18, 19, or even 22 for osmium. So they settle down. And the medium, the density one, will comprise your metal. And the lightest, so previously there was no crust. Previously there was no crust. Crust have developed subsequently. Again, the crust has developed subsequently. Previously there was only mantle, outer core, and inner core. Because of the heating and the melting of the mantle, okay, and further crystallization, the development of primordial or the primitive crust has took place during the heating time. So some of our rocks should be there that belong to that heating time, but we usually don't get, because the preservation of crust during that time is very difficult. Okay, the temperatures are so much high, geothermal gradient is so much high, that whatever is developing, whatever is crystallizing, are eventually getting melted again. So very few part of the crust is being preserved. So there's a crustal building process that took place, that earlier took place since Hadean, and then in Archean, Eoarchean, Paleoarchean, or your up to this 2.8, 2.5 GA. This is the event where there's a, you say, crust building is going on, but not of that much extent that we see in the early and Archean and the late Proterozoic time periods. I hope that you are familiar with this geological time scale, because whatever things I'm telling you, they are already mentioned in the geological time scale. If you don't know, then you should go through the geological time scale. It is one of the basic things everyone should be familiar of by this point of time. Nevertheless, we should move. Okay, so why they are going on? Because of this extensive heating and widespread melting of the primordial metals. Primordial means शुरुआती metal, शुरुआती crust, शुरुआती metal. ठीक है. So इसकी वजह से, इसके crystallization की वजह से, we have developed an oceanic crust. And the development of ocean crust, what is the composition of the ocean crust? This composition of the ocean crust that is developed is similar to that of the ultramafic rocks that we are used to get, like the peridolites. So there's a name called komatiites. Okay, there's a name called komatiites, which is ultramafic rock. Usually, komatiites are the rock that we usually it is not currently formed in any geotectonic setting in the world. So they are particularly restricted to the Archean times, because they have their own mode of formation and condition during conditions, and that conditions are only there during the Archean time. So whenever they ask you, okay, what is the initial composition of the initial crust, so I can write down here, you can also write down here, it is usually ultramafic in nature. It is usually ultramafic in nature, and the name is komatiites. Komatiites. So the name pronunciation is komatiites. ठीक है, तो दो आई है ना उसमें, कोमाटी बोलो फिर आइट्स बोलो. Okay. So this is the primordial crust, and subsequently the rocks that we see in the Archean, some plagogranites or tonalites, or some trogemite type of rocks that we see, that are also representative of the Archean crust, are formed because of the melting of these komatiites. The komatiites are of ultramafic or ultra basic nature. They are dark color. If you visit some Archean terrains like cratons in India, then you could be able to see this outcrop. Some they're not that much widespread, or they are not much extensive. Very limited outcrops are there, because we know that ultramafic rocks have some olivine and pyroxenes, and those minerals are very susceptible to weathering, so they are not preserved that much. So but you could be able to see those comatiites where you see in the cratons. So comatiite के outcrop कहाँ मिलेंगी? I personally seen an outcrop of a comatiites. This you should remember. So now with time, what is happening? The base has been developed. The base is the comatiites, and whatever is happening over the comatiites is because of the partial melting of the comatiites. ठीक है ना? Whatever rocks that we see that are developing over the comatiites, ठीक है ना, are because of the partial melting of the comatiites. So again, the comatiites, because of the huge burden, huge pileup, the lower layers of the comatiites are getting what? Are getting melted because of the huge barrier and also huge barrier and also high geothermal gradient, and the melts that are being produced by the what you say, by the melting of those partial melting of those comatiites are usually more of a basic in nature, basic to intermediate in nature. Okay, so this is the thing, this is the basis of how oceanic crust has been formed. So the continent crust have came after a long time. Usually there is an oceanic crust. Whether oceans existed or not, that we will see. Okay, but because before the ocean existence of the oceans, you need something over which the water can be filled. So that's why the oceanic crust development should be very, very important. Okay. Okay, so this oceanic crust, there are some facts that I have taken from some very authentic book of tectonics. So some fact is mentioned that first oceanic crust first appeared in around 4.5 GA. So they are formed this so usually the ocean crusts are formed around, currently the information that is being given here, it is not something related to what is going on in the Arctic, it is what something related to what is going on currently. So that's why we are formed currently, obviously they are formed in the oceanic ridges, which are the mid-oceanic ridges also, and there are other tectonic settings where the oceanic crust is forming, but the mid-oceanic ridges will make up the huge component. So now composition, obviously if you look at the overall chemistry of the oceanic crust, then it is basaltic in nature, but in the Archean times it was komatiitic in nature. So lateral extent widespread, obviously ocean are widespread, so the ocean crust are also widespread, and they are rapidly recycled. What does that term means, rapidly recycled? Is I hope you can able to see this thing now, rapidly recycled. So this is why they are rapidly recycled. So I will take this pointer. Okay, why they are rapidly recycled? Because they are telling you something about, okay, this oceanic crust get recycled means they get subducted, and again they come into the picture where it usually generated at the mid-oceanic ridges. So in the subduction zone they get subducted, gone into the mantle, again those cycle completed because of the convection, they come again to the surface of the earth from the mid-oceanic. So there's a recycling that is going on, subduction, subsequently your generation of basaltic mat at the mid-oceanic ridges. How generated? We know they are generated at the partial melting of ultramafic rocks in the upper mantle. Okay, so this experiment, it is shown here. I don't know whether I will show you. Just a second. Yes.
Up the bottle and completely
intermixing. So they are showing. I have told you the mechanism how this oceanic crust has been formed. Not oceanic crust, even your layers that are present in the inner earth, how they are formed because of this settling, gravity settling we call it. So this experiment has been well shown here.
up the bottle and completely intermixing the beads and fluid. Note that the two types of beads quickly separate, with the low-density white beads rising to the top of the fluid, and the high-density blue beads settling to the bottom. However, as we continue to watch, note that the white beads start to settle and the blue beads start to rise. Note that this portion of the video has been sped up. This occurs because there are really four substances involved here: two types of beads, rubbing alcohol, and a saltwater solution. After shaking, the combined fluid mixture has a density in between the densities of the two beads. However, over time, the two fluids start to separate, and our final layering is entirely due to density. Alcohol, with a density of about 0.8 grams per centimeter cubed on top,
so what is
then
there?
white
There are
beads,
two types of fluids
blue
that are
beads,
present
and
there.
finally a...
Okay, so you see that the fluid that is present over those white beads are somewhat different in color what is present below that blue beads. It is a reason. So that is alcohol, which is having a specific gravity of about 0.8. Okay, and we have the salt solution. So you see that density is mentioned there upon 1.3 gram per centimeter cube, or 1.3, whatever you say, and the density of the blue beads and the white beads are also mentioned there. So what is there? There is a stratigraphy that is being established. So one is in the bottom, there is a salt solution, then we have a blue beads, then we have white beads, then we have alcohol, based on what is their density. It is the same thing, how the different layers have been formed within the earth. So you can just assume there are different elements. Okay. So I hope you got this thing. Any questions from these two slides? Hello? Hello?
No question.
No question. You are understanding each and everything. Very good. If you have anything, then you can, if you have anything, any doubt, and you are hesitating to interrupt me, so you can drop that in the chat box also. I will pick up that question later on. ठीक है? If you, but पूछना जरूर, ठीक है ना? Ignore ना. Okay, you should ask question, as many questions as you can. Okay. So some facts about this oceanic crust. ठीक है? So oceanic crust is typically 6 to 7 kilometer thick. Contrary to average continental crust, which is around 50 to 35 kilometer. This is the value for the continental crust. Okay, and they are around 15 kilometer thick under islands, means under island arcs. They are saying 15 kilometer thick. Okay, because there is a extensive magmatism that is being taking place, magmatic underplating that is being going on there. Low surface elevation. Obviously, we know that the surface elevation of the oceans are less compared to that of the continents, and mostly submerged below the sea level. Mostly, ठीक है ना? Dark colored mafic rocks enriched in MgO, FeO, and CaO. So, what type of rocks are there? We have understood that these are the basalts. What is the mineralogy of basalt? You have pyroxenes. I hope you are familiar with some things. So these are minerals, some minerals. ठीक है ना? Pyroxenes, and you have some plagioclase. These are some minerals, ठीक है ना, that are present in the basaltic rock. Then you have the average density. Okay, this is a range. This particular density depends upon the mineralogy of the that is present in the rocks. So it is around 2.5 to 3.1, and the age is around. It is not the average age, but it is the, you can say, oldest age, like around 200 MA. ठीक है ना? So oldest is around 200 200 million years, compared to that of the continents which are around Arkansas 3, 3.8, 4.0. Okay. Now you see this particular figure. This particular figure is very, very important from oceanography point of view, and oceanography से ज़्यादा आपको मैं बता दूँ, it is important from tectonics point of view. Okay. So what is shown here? They have shown the stratigraphy. They have shown the stratigraphy of the rocks that you used to get from top to the bottom in the oceanic crust. Okay. So two things are mentioned here, as you can see. One is the equivalent seismic layer, and one is the petrologic units. Okay. One is the equivalent seismic layer. So some people who haven't know what are seismic and what are seismic waves, for them there would be some difficulty to understand this part. This is seismic. It is something related to the layers that are being defined by the geophysicists. And they are being defined by the geochemists. So when we talk about this equivalent seismic, right here, just hold for a second. Yeah. Then this means based upon the velocity of seismic waves in different layers, and this is something related to the rock type. Petrological units. Okay, so this particular oceanic crust is composed of different rock units. Obviously, it is a majority of them. It is basalt, but it is not only basalt. There are other things also. But basalt takes up the majority of the component. You have some sedimentary rocks, some unconsolidated sediments like silt, clay-like sediments. Okay. Then you have sedimentary rocks. Then you have pillow basalts, massive sheeted dike complexes that are ultimately basaltic in composition. Then you have massive gabbros, which is a plutonic version of basalt only. Then you have mafic cumulates, ultramafic cumulates. Cumulates are something that are being deposited in a well-defined manner, horizontal manner. Okay. Okay. So this layer of minerals and minerals and minerals, one over each other. Okay. These are them. Then you have ultramafic cumulates, and you have ultramafic. You just say deformed ultramafic rocks, ultramafic tectonites, or you call it deformed ultramafic rocks. So when the seismic waves, or you say during the seismic, when there is a earthquake, so during what happened during the earthquake, the waves that are being generated, travels the levels the interior of the earth and passes through different layers. So how those different layers respond? What is the velocity? How fast the seismic wave is moving to these respective layers? Their velocities are being mentioned here. As you can see, you see that layer 1 is there, layer 2 is there, layer 3 is there, which is up to this part, and layer 4 is there, which is the mantle only. Okay, so we have water, over which you have the water now. You have the water over which. So this is the oceanic bottom. This is the ocean floor, where I have mentioned You have some sediments, है ना? And this is the water. The complete part is the water. Okay. So you have water, you have layer 1, you have layer 2, you have layer 3, and you have upper mantle. So layer 1, you know, that is the abyssal sediments. Some pelagic, some deep marine sediments are there. You have layer 2, which is the pillow basalts. Layer 3, you have massive sheeted dicomplexes and massive gabbro. Then you have the mantle. Okay. Then you have the mantle, which is the ultramafic. Doesn't matter whether it is a cumulate or a tectonite. A cumulate means just you say that both are igneous in nature, but cumulate are not deformed, while the tectonites are deformed. Okay. That's why they are shown in a very folded manner there. See the fourth layer, they are shown it in a very folded manner. So different velocities are given over in that diagram also and here also. These velocities are very much important. So in water, you see that the PY velocity is around 1.5, then 1.6 to 2.5 in layer 1, 3.4 to 6.2 in layer 2, and 6.4 to 7. So this velocity is increasing with depth. That relation we can make up. And at the then we have the MOHO. MOHO is the first order. This first order unconformity was called it, or a discontinuity that separates the crustal part from the mantle part. Okay. This is the boundary between the crust and the mantle. You have the MOHO. So you see that in this diagram, I'm using some other ink. So it is very important thing that I'm going to highlight. So you see two things are given. One is the seismic MOHO and one is the petrologic MOHO. Two things are given. One is the seismic MOHO and one is the petrologic MOHO. Seismic MOHO says that okay, the MOHO lies between the ultramafic cumulates and the mafic cumulates. Okay. So seismologist or the geophysicist says that आपकी जो MOHO है वो आपकी कहीं your 3B and 4 के बीच में, वहीं geologists कहते हैं it is somewhere lying between the ultramafic cumulate layer and the ultramafic tectonites, because our ways of differentiating things are different. So हम एक ग्रुप ऑफ साइंटिस्ट है जिसने मोहो को डिफाइन किया ऑन द बेसिस, किस बेसिस पे आपका, कि आपकी seismic wave velocity क्या है. And the seismic wave velocity depends very much on the mineralogy, I would say, on the mineralogy. So your mineralogy is different in the ultramafic and the mafic cumulate. Here, I'll highlight this thing at this boundary. Okay. So this is the seismic. So mafic and ultramafic cumulate, because both are different rock types, both have their different set of minerals, and both have their different set of minerals, and different set of minerals have their own unique physical properties and the crystal system. And that particular thing, what is the nature of the solid matter, defines how well the seismic waves can travel through it. So it depends, very much depends upon the physical properties of the solid matter. Like we call it, we usually call it some high-tech term is there, we call it elastic models, densities, like your bulk models, your shear models, okay, and your what we call it density as well as, okay, as well as density. So these things are there. कौन सी चीज है? Shear modulus. I will write this thing here in the bottom part. You have shear modulus. These are the things over which your seismic wave, either it is a P wave, which is a primary wave, or either it is a S wave, which is a secondary wave. P waves are also called as the longitudinal wave, but the S wave are also called as the transverse waves. So your shear modulus is there, your bulk modulus is there, and your density. So these properties vary from solid to solid. Okay, so if you have pyroxene, for example, and if you have plagioclase, which I have mentioned here, for both of these minerals, the properties would be different. Okay, the both of these minerals, the properties would be different. Okay, so yeah, this is an important thing that you should remember. अभी किसमें ज्यादा होगी किसमें कम होगी we are not dealing with that currently. It is some different aspect. It is aspect that we have to cover in seismics and seismology. Okay. By taking out the this is the bulk modulus of pyroxene is this much, shear modulus of pyroxene is this much, similarly for plagioclase is this much, and we can respectively calculate what is the P wave velocity, and obviously and it matters on the minerals also, and also matters how much percentage of pyroxene and how much percentage of plagioclase are present in the respective rocks, like in gabbro, like in basalts. Textures are different. For a massive gabbro and a massive gabbro and a mafic cumulate, texture are different. That's why there is also a contrast. Okay, that is why there is also a contrast. For water at C, it is 1.5. It is not even a solid; it is a liquid. That's why the value is so much less. Correct. Yeah, the value is so much less. But geologists say, okay, it is something based on the rock types we usually encounter with depth. And the question is, how we used to know the composition of the whole oceanic crust? Like how we know that, okay, this is your sediments, this is your Africa, this is a below basalt, and how we know? We know based on some drilling data, because there are some IODP, International Oceanic Drilling Program. There's a drilling that is going on. They used to drill at different locations, and they collect those sediments, and those sediments can be sediments as well as basaltic layers. Obviously, the pillow lava. Because the drilling we couldn't go much deep, up to 2.5 kilometers max to max, because we are still going 4 kilometers deep with this ocean. And ocean के नीचे आप 2.5 किलो से 3 किलोमीटर max to max. But still, जो चीजों की हम बात कर रहे हैं, just see the average thickness of them. Just see the average thickness is also good. We can't reach to layer 3. Yes, we can in some cases if the upper layers are thin enough. But still, we don't know the composition of the 3B or 4 layer. We can't reach up to the mantle in any case. So, from where we used to know the composition of the mantle, whether there's existence of this ultramafic cumulates and ultramafic tetralanites, because they have well placed that boundary, that MOHO boundary there. कैसे पता चला? We know it from the mantle xenoliths. They are rocks that usually come to the Earth's surface from the volcanoes, and they sometimes they take that mental part with them. ठीक है ना? कुछ रॉक्स होती हैं जो आपकी वॉल्केनो से निकलती हैं, तो क्या होता है उसमें आपका जो मेंटल जो पार्ट होता है, मेंटल की जो रॉक्स का जो पार्ट होता है, कंपोनेंट होता है, वो आपका स्टिल प्रिजर्व होता है. इट इज स्टिल प्रिजर्व, इट इज नॉट मेल्टेड. ठीक है ना? The rocks constitute that mental part, and they are not melted. Okay, now we call it the xenoliths. From xenoliths, we can see, okay, this is the xenoliths. Then then it itself means that these are of the these are the representative of the mental. These annulates are the representative of the mental, and by doing the geochemistry, we used to know the composition of the lower crust, lower oceanic crust, as well as the upper mantle. So we have placed that boundary there. Okay, now. So this is the overall structure of the oceanic. You should remember it from top to bottom. You should also remember it layer 1, layer 2, layer 3, A3B wise. And you should also remember the average thickness as well as the P wave velocity, which I have mentioned here. Okay, which I have mentioned here. If you have any questions, then please ask me, because it is a very important slide. These three, 4, 3, 2 slides are very, very important. Okay. Any questions there? No questions? No doubt? Okay. If you have any, then you can ask me later on also, but please do ask. Okay. A lot of questions you can expect that would arise from this slide and from the previous slide. Okay. A lot of questions. So please don't ignore. Maybe हो सकता है कि oceanography में ना पूछे. हो सकता है they can ask in from seismic aspect or from tectonic aspect, from physical geology aspect. ठीक है, so you can't please. और आपका ये चीज important इसलिए होगी, आपका mineralogy is very important. It is also important from petrological thing also. तो सब बहुत सारे सब्जेक्ट्स का डेटा लेके इस तरीके की चीजें एस्टेब्लिश की गई हैं, ठीक है ना. इसमें आपका seismology, इसमें आपका mineralogy, petrology, your tectonics, all things are being there. ठीक है. Okay. Usually, in if you see some standard universities, then this particular part, this we usually call it ophiolite sequences, or oceanic crustal stratigraphy. We usually study in tectonics and in igneous petrology. But still, I'm telling you in the oceanography. Okay, this is the distribution of the oceanic crust age-wise. Okay, distribution of the oceanic crust age-wise. So we have seen in the previous diagram that the older oceanic crust, older, you कह सकते हैं, हाँ, okay, 180, oldest is around 200 somewhere. You see that in this particular color bar that has been mentioned here in the bottom, you see that 0 represents reddish color. So as well as we are moving, then we have got orangish, yellowish, greenish, then we have some bluish, violet, indigo, and then the purple lastly. Okay, so the more bluish की तरफ अगर हम जाएंगे, it is the oldest one. More reddish की तरफ है, it is the most youngest one. You see that you can make a strong correlation by looking at this global tectonic map. Along with this, some other informations are also shown. They have removed all the water, so you can able to see the ocean. Again, the ocean are well exposed. So you see that different features are clearly visible. In which the most important feature is the mid-Atlantic ridges, mid-oceanic ridges, correctly we say it. Okay, so mid-oceanic ridges you see. Okay, these boundaries. Hope you can see those boundaries. Okay, they're going like this. I hope you can able to see them properly. This overwriting, so you can see that properly from your side. समझ में आ रहा है? हेलो, ठीक है, समझ में आया? So you have different plates. These meteorological bridges, what they do, they divide different plates. Okay, we are not going into that, but you see that strong correlation that the youngest oceanic crust is lying near to this mid-oceanic ridges, and the oldest ones are lying near to the continents. Okay, and the older ones, better to say, and the oldest one is there here. What is it? This is the Mediterranean Sea. ठीक है ना, ये आपका मेडिटेरियन सी का पार्ट. So so whenever the crust is forming, we know the crust is forming at the mid-oceanic ridges. So obviously, the juvenile crust we are going to get there only, and the crust, oceanic crust, what there is like conveyor belt, and the crust, oceanic crust, wherever it is formed, it is moving away from the ridges because you have to give space for the formation of the new crust. So newer crust will take the occupy those spaces that is being occupied by the older crust previously. So the older crust will move away from the mid-oceanic ridges, and a new crust will start forming continuously. It is a continuous process. It is also going on currently on the Earth. The continuous process. So you see that bluish color you see, okay, North America and this African parts, okay, you see that in India also. If you see what is in India you see that, okay, the usually the crustal age is around 100. This, see the color, I'm giving this age based on the color that I will be able to see. ठीक है ना, अगर आप देखिए तो it is more of a greenish color in the eastern side and younger yellowish colored on the Arabian Sea side, western side. See that? You can.
सर
Yes.
सर एक बार हिंदी में थोड़ा सा एक्सप्लेन कर दीजिएगा.
Can you please repeat again?
सर हिंदी में एक्सप्लेन कर दीजिए एक बार
अच्छा,
थोड़ा डाउट.
ठीक ठीक ठीक, कोई इशू नहीं है. I can explain it again also. Okay. So in this global map, again I'm telling you, in this global map, what they have shown is the age of the oceanic lithosphere. ठीक है ना, the distribution of the oceanic lithosphere according to its age. So what they have done, they have removed all the water, so you can see the oceanic crust. Obviously, the oceanic crust is now exposed. Previously, it was hidden, छुपा रहता है आपका ओशन के नीचे. तो आप देख सकते हैं कि you can make a strong correlation that the younger oceanic crust, ठीक है ना, is lying very near to the mid oceanic ridges that I have marked, that I have highlighted. ठीक है ना, and whenever we are moving away from the oceanic ridges, the crust is getting older and older. We are specifically talking about the oceanic crust. We are not talking about the continental part. अभी अपना उतना बात नहीं कर रहे हैं, उसमें इंफॉर्मेशन शो भी नहीं की गई है, ऐसा कुछ कलर रिप्रेजेंट नहीं किया गया. देखिए आप कॉन्टिनेंट पार्ट, ठीक है ना, वो मेनली और फिजियोग्राफी के बेसिस पे कलर रिप्रेजेंट, कहीं जंगल है तो आपका ग्रीनिश कलर शो किया गया है, कहीं डेजर्ट्स हैं तो आपको येलोइश कलर शो किया गया है. तो कॉन्टिनेंट्स को आप इग्नोर मार सकते हैं. मेनली ये डायग्राम फोकस आपका किस पे कर रहा है, या ओशन के पार्ट पे. ठीक है, तो क्या हो रहा है आपका, बिकॉज द न्यू क्रस्ट आपका क्या कहां फॉर्म होता है, आपका नया क्रस्ट आपका मिड ओशनिक रिजेस पे फॉर्म होता है. आप देख सकते हैं कितनी एक्सटेंसिवली फैली हुई है ये मिड ओशनिक रिजेस, हर जगह पे है. ऐसा कोई ओशन नहीं जिसके नीचे ना हो. इन्हीं की वजह से आपकी ओशन की ओपनिंग होती है. सो ओशन ओपनिंग गोइंग ऑन, ठीक है ना, रिफ्टिंग गोइंग ऑन, चीजें एक दूसरे से दूर जा रही हैं, ओशन बेसिन फॉर्म हो रहा है आपका, और आपका बसाल्टिक क्रस्ट जो है डेवलप हो रहा है। ठीक है, तो हम देख सकते हैं जैसे जैसे हम फॉर एग्जांपल वी विल टेक एग्जांपल ऑफ दिस फ्रॉम हेयर टू हेयर। From here to here, we see that okay, at different places, if you take the samples right away from the mid ocean ridge, first sample आपका यहाँ पे लिया गया है, गर्म होगा सैंपल क्योंकि अभी अभी रॉक बनी है। फिर जैसे जैसे हम दूर जाएंगे क्या होगा, सैंपल जो है आपका ठंडा होगा क्योंकि हम लोग दूर जा रहे हैं, ओल्डर होगा। तो जैसे जैसे हम लोग मिड ओशन रीज से दूर जाते हैं और कॉन्टिनेंट्स की तरफ अप्रोच करते हैं, तो क्रस्ट आपका क्या होता है, तीन चीजें याद रखिएगा। क्रस्ट आपका ओशनिक क्रस्ट आपका थिक होता है, पहला याद लिख लीजिए। जैसे जैसे हम लोग दूर जाते हैं ओशनिक क्रस्ट आपका थिक होता है, इट गेट्स कोल्डर एंड इट्स गेट ओल्डर, ओल्डर कोल्डर थिकर। ठीक है ना, ये चीज आप ध्यान रखिए। Understood? So this is the things I am usually telling you. Okay. Similarly, case arises here. और मैंने फिर बाद में क्या दिखाया, because sometimes question would arise that इंडिया के पास क्या सीन है। तो इंडिया के पास you can see that what is the scene that आप देखिए, ये पूरा कलर एक बढ़िया से पैलेट दिया हुआ अच्छे से, डिफरेंट डिफरेंट कलर्स शो किए गए हैं, ग्रेडियंट शो किया गया है, ऐसा नहीं है कि बार्स टाइप शो किए गए हैं। तो हाँ, आपका एक ट्रांजिशन है कि लाइक रेड कलर धीमे धीमे चेंज हो रहा है ऑरेंज में, देन ग्रीन, येलो में, देन ग्रीनिश, येलोइश ग्रीन, ग्रीन, देन ग्रीनिश ब्लू, वायलेट। ठीक है ना, लाइक दैट। तो धीमे धीमे ऐसे कलर आपका ट्रांजिशन। तो इसके बेसिस पे मैंने ध्यान से देखा और मैंने देखा कि ओके, इंडियन प्लेट के आपके दिस इज योर, दिस इज नॉट योर इंडियन प्लेट, दिस इज योर इंडियन कॉन्टिनेंट। ठीक है, you see that this part, this Arabian Sea part, and this is the Bay of Bengal part, eastern part and the western part. Okay, so in this eastern part you see that majority of the oceanic crust is of this much age, as been represented by the color. मैं ऐसा कुछ कहीं information लिखी नहीं, बस मैं color देख के बता रहा हूँ इससे। It is around 100 million years, while on the this side it is around 60 million years. So, हम ये कंक्लूड कर सकते हैं दैट आपका ये वाला जो पार्ट है वो आप पहला पहला होता नहीं है, हम लोग जब आपने बुक्स को पढ़ा होगा गोंडवाना लैंड असेंबली का, जब एक साथ थे और रिफ्टिंग स्टार्ट हुई, तो आप ये कंक्लूड कर सकते हैं कि जो ईस्टर्न साइड की जो रिफ्टिंग है वो पहले स्टार्ट हुई है। ठीक है ना, बिकॉज द rocks that we are getting on the eastern side are more older compared to the rocks that we are getting on the western side. Madagascar और अफ्रीका बहुत भी डिटैच हुआ है आपसे। So we can conclude this type of information by looking at this particular map. Very good map, very strong information it holds. And exception, but this is the exception. ये क्या है भाई? ये क्या? What is this? While we are getting crust of around 240 260 years, it is because that is the remains, Mediterranean Sea is the remains of the Paleotectonic Sea that was existing previously when Himalayas are collided, have to be collided with the erosion plate. So there's a sea that existed between that Indian plate and the Eurasian plate, which is the Tethys Sea, and this Mediterranean Sea is kind of a relict of that Tethys Sea. ठीक है ना, अवशेष बोला जाता है, रिलेट को अवशेष है आपके। ठीक है ना, तो दैट इज व्हाई वी गॉट द एजेस अप टू दिस मच, 280, इवन मोर देन दैट, 300 के अबव भी हो सकते हैं कुछ अगर सैंपल्स आप, क्योंकि ओशन क्या होते हैं, ओशन रिसाइकिल, समय के साथ साथ क्या करते हैं, ओशन आपके रिसाइकिल होते हैं। तो आपको यहाँ अच्छी समझ में आ गई मैं क्या बोलने की कोशिश कर रहा था आपसे? हेलो,
यस सर।
ठीक है, एनी अदर डाउट?
नो सर।
आपको किसी में भी डाउट है इन चारों स्लाइड्स में भी? Okay, this so we couldn't be able to complete this part, but we have completed this part, the structure, composition, and the mechanism of the formation of the oceanic crust. ठीक है ना, हम लोग ने ये पार्ट कंप्लीट कर लिया। सो टुमारो वी विल डील विद द मॉर्फोलॉजिकल एंड टेक्टोनिक डोमेन्स, क्योंकि इससे पहले आपको ये जानना जरूरी है कि फॉर्मेशन क्या हुआ, क्योंकि अल्टीमेटली अगर आप ये समझोगे कि फॉर्मेशन कैसे हुआ, देन वी सी द ओके व्हाट इज द this what are different tectonic domains and how our oceanic topography would look like. Then we move up to the hexography, physical and chemical properties. देखिए पहले हम क्या बात करें, शुरू से शुरू में इंट्रोडक्शन के बारे में पहले बेस पढ़ा, बेस के बाद ओके क्या क्या एस्पेक्ट होते हैं, जियोमॉर्फोलॉजी क्या है, एक तरीके से मॉर्फोलॉजी क्या मतलब, जियोमॉर्फोलॉजी हम लोग पढ़ते हैं कॉन्टिनेंट्स पे, हम जियोमॉर्फोलॉजी पढ़ रहे हैं ओशन के नीचे जितने फीचर्स हैं, बस टेक्टोनिक फीचर्स के बारे में पढ़ेंगे हम लोग और मॉर्फोलॉजिकल फीचर्स के बारे में पढ़ेंगे, ठीक है ना। देन हिप्सोग्राफी, कैसे आपके एलिवेशन चेंज होते हैं, एलिवेशन और एरिया का क्या डिस्ट्रीब्यूशन है। फिर इसके बाद क्रस्ट आ गया, उसके बाद पानी आएगा, पानी की प्रॉपर्टीज पढ़ेंगे, सी वाटर की फिजिकल केमिकल प्रॉपर्टीज बहुत इंपॉर्टेंट है, बहुत ज्यादा क्वेश्चन इस पे आते हैं। क्या स्पेशल वेरिएशन, स्पेशल वेरिएंस मींस कैसे आपका डिस्ट्रीब्यूशन हो रहा है। फिर इसके बाद रेसिडेंस टाइम, ये बहुत छोटा कंपोनेंट है, ये 2-3 स्लाइड में निकल जाएगा ये भी। देन द मेन थिंग कम्स ओशन सर्कुलेशन, कोरियोलिस इफेक्ट, एक्मन स्पाइरल, कन्वर्जेंस, डाइवर्जेंस एंड क्वेलिंग, ocean currents, waves and tides, so very strong subtopics. A lot of question arises from here, ठीक है ना, ये वाले पार्ट बहुत ज्यादा important है। This is the thing where the actual I think the oceanography start, because this parts we usually study in other aspects also. In physical geology में किसी ने अच्छी पढ़ी होगी तो आप ये सब चीजें बात करें, लेकिन नीचे जहां से हम ओशन सर्कुलेशन की बात करते हैं, थर्मल एंड सर्कुलेशन की बात करते हैं, that is the pure oceanography that usually expect. ये आपके क्वेश्चन नहीं बन सकते, ऊपर वाले क्वेश्चन हो सकता है बना भी लो आप एक बार जियोलॉजी पढ़ के, लेकिन आप नीचे वाले क्वेश्चन नहीं बना पाओगे, उसके लिए आपको पढ़ना पड़ेगा। फिर इसके बाद हम लोग देखेंगे वो नेक्स्ट वाली स्लाइड जो थी मैंने नहीं लगाई थी, बस उसको दिखाने के लिए लगाया मैंने, ठीक है। इसके बाद और भी टॉपिक्स की लिस्ट थी, 7 टॉपिक्स और थे इसके बाद, तो कोई नहीं हम लोग देखेंगे। और जितना भी फैक्ट्स मैं बता रहा हूँ प्लीज आप उसको नोट डाउन करिए और मुझसे क्वेश्चन पूछिए अपकमिंग लेक्चर्स में। इसको मैं चेंज कर दूंगा, चेंज इट टू स्ट्रक्चर, कंपोजिशन एंड मैकेनिज्म ऑफ फॉर्मेशन ऑफ ओशनिक क्रस्ट, ठीक है। देन वी मूव टू द नेक्स्ट पार्ट व्हिच इज द ओशनिक क्रस्टल टाइप्स, डिफरेंट क्रस्टल टाइप्स, ठीक है।